Hello, we're going to work a molarity problem for chemistry class. Our problem is, what is the molarity if 14.72 grams of potassium chloride is dissolved in water with a final volume of 893 milliliters? So what is the molarity? Our periodic table on the back has the capital M for molarity, and we see that it equals the moles of solute over liters of solution. So let's write that down. Molarity equals moles solute over liters solution. Moles of solute over liters of solution. Okay, so we need to identify our solute. Again, the question reads, what is the molarity if 14.72 grams of potassium chloride is dissolved in water with a final volume of 893 milliliters? So, the 14.72 grams of potassium chloride is what we're dissolving in the water. That makes it our solute. And now for our equation, we need moles of solute, not grams. So the first thing I need to do is to convert my grams to moles. To convert from grams to moles, I need to know what potassium chloride is. So potassium is K. Chloride stands for chlorine, which is Cl. So I need to make the formula for potassium chloride. Whenever we put a metal and a nonmetal together, we have to look at the charges. Potassium is in the first row of our periodic table, so it is charged +1. Chlorine is a halogen next to the noble gases in our periodic table, so it has a charge of -1. So actually, potassium chloride already adds up to 0 with a +1 and a -1, so the formula is KCl. Just one of each is needed, but we always have to check our charges when we write the formula of an ionic compound. So we're ready to change our grams to moles. We have 14.72 grams of potassium chloride. I need moles to go into my formula. So we're going to convert using the molar mass of potassium chloride. So I need to add the mass of a K, which is 39.10, to the mass of a Cl, which is 35.45. When I add those two together, I get 74.55 grams in the 1 mole. Because grams is what I started with, grams of KCl must be what's on the bottom, so it'll cancel out. And we added it up to be 74.55 grams of KCl in the 1 mole of KCl. Grams of KCl cancel out. So I'm going to take 14.72 divided by 74.55 equals 0.1975 moles of KCl. That number can now go into my equation for molarity, which is the capital M. So my moles of solute, I just figured out, is 0.1975 moles. Now I need liters of solution. Well, we were given our final volume of the solution is 893 milliliters. However, I need liters. So I need to convert 893 milliliters to liters. How many milliliters are in a liter? Do you remember? If you said 1,000, you are correct. Because milliliters is on top, milliliters must go on the bottom. And we just said there's 1,000 milliliters in the 1 liter. So we have 893 divided by 1,000. And that gives us 0.893 liters for our solution. So that number now plugs back in to the denominator, liters of solution. We just calculated that to be 0.893 liters. So now I have my moles of my solute, which was my potassium chloride, and I have liters of solution, 0.893 liters. So I need to divide these two numbers. 0.1975 divided by 0.893 equals, and I get a long number, so I need to pay attention to sig figs. My top number has 4 sig figs. My bottom number, however, only has 3, so I do need to go with 3. So this will round to 0.221 because 1 doesn't round up. So 0.221. 0.221 moles per liter. The units did not cancel out, they're still there. Moles over liters is simply written as moles per liter. And that is our final answer for the molarity. Thank you. Hope you view the next video. We'll do a more difficult molarity problem next. Thank you.